What caused the Tunguska event's missing evidence? Imagine a massive explosion ripping through a remote Siberian forest in 1908, leveling trees over an area of about 2,000 square kilometers. That's exactly what happened during the Tunguska event. Despite releasing an energy equivalent to between 3 and 30 megatons of TNT, scientists have never found a crater or large meteorite fragments at the site. This mystery has puzzled experts for over 100 years. The main reason is that the object responsible for the explosion didn't actually hit the ground. Instead, it exploded high up in the sky, roughly 10 to 14 kilometers above the surface. This kind of explosion is called an airburst. When the object exploded in midair, it released a shockwave powerful enough to flatten trees but left no impact crater because the asteroid or meteorite disintegrated before reaching the ground. Most scientists agree that a relatively small asteroid, about 50 to 80 meters wide, entered Earth's atmosphere at a very high speed. The intense heat and pressure caused it to explode before impact. Some research suggests the object was made of iron, which skimmed through the atmosphere and continued back into space, leaving behind only vaporized dust and tiny mineral particles in the soil. These microscopic remnants are very hard to detect. The absence of a crater and meteorite debris also rules out a comet, which is mostly made of ice. Icy bodies tend to vaporize higher in the atmosphere, which matches the damage pattern seen in the trees. Early expeditions found no large fragments or strewn fields, only a radial pattern of scorched and downed trees, confirming an airburst rather than a direct impact. Some more speculative ideas have been proposed, like a primordial black hole passing through Earth, but there's no solid evidence to support that. The missing physical evidence from the Tunguska event boils down to the explosion happening high above the surface. It vaporized the incoming object and dispersed its material into tiny particles that are nearly impossible to find. This is why the event remains one of the largest recorded airbursts in history, with such little physical trace left behind. Did you know that scientists continue to study tiny mineral traces and patterns of tree damage to better understand what really happened?